Hello students, welcome back. Let's go to section 3, lines. I know everybody went through lines through and through in elementary and then again in intermediate algebra, but let's review a little bit. It's an optional lesson, so if you want to skip, go ahead and skip this video and let's meet again in section 4. That's fine with me. Alright, the first concept is a slope concept. Rise over run, or the difference of x coordinate, or difference of y coordinate over the difference of x coordinate, delta y over delta x. Here delta, Greek letter delta, represents the difference. So delta x is difference x2 minus x1. Delta y is the difference y2 minus y1. So difference of y coordinate over difference of x coordinate is rise over run, and that's a slope. Here's some equations of lines, and this is something I believe everybody's already comfortable with, but let's do it again. The general form, ax plus by plus c equal to 0, and a and b and c can be arbitrary. And here's one, and then run it again. This program is semi-randomized, so each time I run, I'm going to get something different. And then flip the c to the other side so that you can write ax plus by equals to some constant k, like that too, if you want. Either way, it's a general form. Next, the slope-intercept form. Not everything in the general form can be written like this. In a special case, if this b is non-zero, then you can rewrite slope-intercept form like this. By the way, here, this b and that b over there are two different b's. Don't get confused. I'm just using the expression from our textbook. So even though I use b here and that b here, those two b's are completely different b's. One b is from general form, the other b is from slope-intercept form, and b is the y coordinate of the y-intercept, so 0 comma b, and then in this case m is 1.01 something, b is 1.08 something, and you can run it over and over again for various slopes and various y-intercepts. Those are slope-intercept form. Next, slope point form. Wait a minute, why do we have A and C instead of B? Sorry about this typo. Okay, that should be C, and that should be D, and that should be E. Sorry about that. Slope point form with a slope, but running through x0 comma y0. I prefer to have it this way, but many people prefer the other way, flipping this y0 to the other side. Either way, it's okay. Like this, running through x0 comma y0, and the slope is negative 1.77, kind of like that. Let's run it again for some different m and x0, y0 values. In a special case, y0 is 0, then no, in a special case x0 is 0, then this one just drops out. It's the same as slope-intercept form over here. Next, 2-point form, running through the points x1 comma y1 and x2 comma y2. The slope formula here, the difference of y coordinate over difference of x coordinate, y2 minus y1 over x2 minus x1 becomes the slope, and running through x1 comma y1 coming from the slope point form. So we have these 2 points, and then these 2 points generate the slope, and then running through first point. And this program is randomized too, so you can do all kind of things with these. Horizontal lines and vertical lines. Horizontal lines have slope 0, so we have y equals to b, and vertical lines do not have any slope. Rise over run, there's no run, so denominator is 0. In this case, we have x equals to a with no slope. So here, horizontal lines, we do have slope. Slope is defined, and slope is just 0. Vertical line, undefined slope. This distinction, especially for undefined slope for a vertical line, this will become important in calculus. Okay, those are equations of lines. Examples. Express those in slope-intercept equation. Oops. Okay, basically solve for y. Yeah, I can do that. Like terms together, flip 2x to the other side and solve for y. And here, something more complicated. Doesn't matter. Break up the parentheses, take like terms together, and solve for y. Break up parentheses, take like terms together, eventually solve for y. If you have some denominator, still don't be intimidated. Step 1 is removing the denominator. Oh, if you do it right, you're going to get this form, and I didn't show you anything. Okay, alright, I'll leave that to you. How about this example? Find the slope-intercept equation of the line that runs through the given pair of points, and the pair of points are these two. Okay, all you have to do is to put those into the 2-point form. x1, y1 is the first point, x2, y2 is the second point. Put this one into this, and then just simplify, break up the parentheses, take the like terms, and that's going to be your slope-intercept equation. So, 2-point equation here, and let's simplify. Negative 2/3 is the solution, and then break up the parentheses and take the like terms together. What comes out as a final result is a slope-intercept equation. Not really worthy of any further class time. How about this? Find the slope-intercept equation of the line that has slope negative 1/3 and runs through the midpoint. So slope negative 1/3, and then point is this one, slope point formula, but that point is neither 2, -1 nor -4, 3. It is the midpoint of the two. So the midpoint is the average point, -1, +1, and then you can use the slope point equation for that. x0 is -1, y0 is 1, and then m is the slope, negative 1/3. So here's the equation. Nobody writes as negative of -1, so write it as +1 there. Break up the parentheses, take the like terms. In the end, what comes after as the final result is the slope-intercept equation. Well, all these would be good problems in elementary and intermediate algebra, but for us, not really worthy of a great deal of class time. Parallel lines and perpendicular lines. Okay, this may be a bit weird. Parallel lines means the same slope. Perpendicular lines means negative reciprocal. And then intercepts. Yeah, okay, usual technique. Put y 0 and solve for x. Put x is 0 and solve for y. And if you want to solve that in general, you're going to get this form, the intercept form of the equation of the line. No, I don't think that's important. The scheme, this is important for all cases, in general, for nonlinear equations too. Let's see, do we have an example problem here? Find the slope-intercept equation of the line that is parallel to this line and then runs through this. Okay, slope is 2/3, and then running through -2 comma 1, and we know the slope point equation. You can easily do it. Yeah, slope, and then running through -2 comma 1. Simplify, break up the parentheses, and take the like terms together. What comes as the end result is a slope-intercept equation. So this is the equation we're looking for, and the light line, that is the starting line. Not very important. Find all intercepts of the line you just found. Yeah, okay, alright. From here, find all intercept. Put x is 0 and find y. Put y is 0 and find x. Put x is 0 and find y for y-intercept. Put y is 0 and find x for x-intercept. Find the slope-intercept equation of the line that is perpendicular to this and runs through this point. Perpendicular to this, so it's going to be negative reciprocal. So the slope is -3/2. -3/2. That's the new slope. Negative reciprocal. And then running through the point -2 comma 1. It's the same as before. +2 +1, and simplify. In the end, you get a line that is perpendicular to the first line and running through -2 comma 1, like this, green. And then find all intercepts. Okay, alright. Plug in x equal to 0 and find y. And plug in y equal to 0 and find x. Okay, those kind of things there. There are many more, of course, but they're all thoroughly covered in intermediate algebra, and actually even before that, elementary algebra, and even pre-algebra too, as a matter of fact. So I don't think there's any need to spend any more class time on section 3, but that doesn't mean I'm not going to write any problem on lines. I will. I just expect everybody already knows. Okay, so much for section 3. Let's go to section 4 in not an optional, real lesson video.